Now let's continue. So we are now in what? Aliphatic compound. Aliphatic compounds. So we are now in what? Aliphatic compounds. So let's quickly do them. So the aliphatic compound, they are like stretch chain like this, like methane that I draw, like ethane that I draw. They are what? They are aliphatic compound. They are aliphatic compound. So they are all what? Aliphatic compound. I hope you understand. So all of them, they are what? Aliphatic compound, because they are chains. If you look at it, it's like what? Chains. So they are what? Chains. Now let me go to a place. We now have what we call alicyclic compounds. Alicyclic compounds. What are alicyclic compounds? Let me use different color. So alicyclic compounds, they are the compound in cyclo form. For example, now you know that propane, if you use the formula for the alkene CnH2n plus 2, you know that propane is what? N is equals to 3, like that. I hope you understand. So if you put 3 here, it will now be C3H8, right? So in alicyclic, if you want to draw propane, cyclopropane in cyclic compound, this is how you will draw it. So on each carbon, you'll be putting 2 hydrogen on each carbon. You'll be putting what? 2 hydrogen on each carbon. So if you count the number of hydrogen, count the number of C, it is what? C3. Count the number of hydrogen, 1, 2, 3, 4, 5, 6. So it's now what? C3H6. So it means a cyclopropane is different from a normal propane. You know that a normal propane is C3H8, but a cyclopropane, it will be what? C3H6. So it means cyclopropane is 2 hydrogen atom deficient to the main propane. I hope you understand. So these are alicyclic compound. So it means for butane, that is C4H10, the cyclopropane butane will be what? C4H8, which means cyclobutane is equivalent to what? Butane. I hope you understand, because the formula for the alkane is what? CnH2n. It means for butane it will be what? C4H8. I hope you understand. So it means cyclobutane is equals to butane. I hope you understand this, the logic. So now that's that for alicyclic. But you can also draw alicyclic in another way. Apart from drawing it this way, you can draw it like this. If you draw something like this, you have drawn propane. If you draw something like this, you have drawn cyclohexane. Don't mistake this for benzene. This is not benzene. Please take notes. Benzene, before you can say it is benzene, it is whenever you see double bond inside it, or you see circle. If there is no circle inside it, it does not become benzene. Okay, let me draw it next slide. This is benzene. This is what? Benzene. This is benzene. But whenever you see something like this, it also have what? 6 sides, but you don't see anything inside it. It is called what? Cyclohexane. Hope you understand. So they are different. And benzene, you can also draw it like this, according to August Kekule structure. You can draw it like this. So it has many structure. So we are not yet in benzene, so we are still doing some aspects. So now we are going to aromatic compounds, which require that dose of benzenes and all that. But everything is not about benzene under aromatic compound, but they are benzene like structure. So So now we are now in what? Aromatic compounds. Aromatic what? Compounds. So what are aromatic compounds? They are the compounds that has aroma. So their root word, it was derived from the word aroma. So they produce aroma. So that's why. So their main compound is what? Benzene. Benzene. And what is the general formula for the aromatic compound? It is CnH2n minus 6. But I think their first member started from n is equals to 6. So don't go and input 1, because if you input 1, you'll be having minus here, and if you are having minus, you are wrong. So input 6. Okay, let's input 6. We are now going to be having 6. Then 2 times 2 here, that's 12. 12 minus 6, that's H6. So that's the formula for benzene. Let's draw the structure of benzene. So this is the structure of benzene. So it is still different from the one I wrote here. So benzene can be drawn in several ways. I hope you understand. So you can start putting your double bond here. Then you will leave one space. Then you still put another one here. You still leave another space. You will still put another one. So that's the last thing. So it means benzene has 3 double bonds in its compound. So this is how you write the structure of benzene. You will now be putting hydrogen on each carbon. You'll 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 be putting hydrogen on each carbon. So if you count the number of hydrogen, so we have 1, 2, 3, 4, 5, 6 carbon. 1, 2, 3, 4, 5, 6. If you count it, we have equal number. So this is how to draw benzene. So you can also draw it in another way. So it depends. So you can see, draw it like this. You know that we started our double bond here. So let's start here. Let's start from this place, from the left side here. You will lift one space. You will lift this place and go and move to the next space. So let's go. You will leave this place also. You go to this place. I hope you understand. So that's that about the structure. Then you'll be putting hydrogen on each of them. So if you notice, we can draw benzene in more than one way. So if they ask you which property does this signify, which property does this signify? So this property is called what? Resonance. So if they ask you which property does benzene exhibit that makes it to have more than one structure, so it is called what? Resonance. I hope you understand. So this structure again, I can still redraw it in another way. So I will show you in the next slide. So instead of drawing it like this, I can still draw it in another way. So I can draw it without showing the number of carbon. I'll just draw it like this. Just draw it like this. Just draw it like this. I can start for my I think you can see it. I can start here. I can start here. I can start here. I hope you understand. So let me start here. I will leave this place. I will still put it here. I hope you understand. I will leave this place. I will still put it here. I hope you understand. Or I can still draw it like this. I will start from this place. 1. I will leave a space. I will start again. I will still leave a space. I will still start again. So this is the two structure. So another structure. That's not all. Now this is the latest structure. If they ask us which scientist gave us, or the chemist that gave us this structure, it is called Auguste Kekulé. So it's the person, Augusto Kekulé, gave us this what? Structure. He was the one that gave us this incredible structure. So now the scientists have discovered a new structure for benzene. It was the structure I drew earlier. So the structure is this. So whenever you see something like this and you put 0 at the enter, it is also what? Benzene. Hope you understand. So this is the formula for benzene. This is the modern structure for benzene. Modern. Although these structures, they are not that correct, but if you draw it, you are still correct. So if you draw it, but in the jam, you don't need to draw something in jam, but you may see it in an option. So I hope you understand. So that's it. So let's still continue. Now, there are some benzene-like structures that you need to know. Benzene-like structure. So those structures like naphthalene, anthracene, and stuff like that. So you need to know them. So naphthalene, if you want to form naphthalene, this is what you will do. You will join 2 benzene together, then you will form naphthalene. You will join 2 benzene together. Sorry, don't mind my structure. You will join 2 benzene together. So that's how you get your naphthalene. So this is the structure for naphthalene. Now let's put the double bond. You put the double bond here, put one here, still put another one here, but here you will not put double bond again. So we now start here, then you put it here. So this is the formula for what? Naphthalene. So it's also a aromatic compound, naphthalene, that is C10H8. So that's its own formula. Now let's draw the structure for anthracene. So anthracene can be formed by joining 3 benzene-like structure. Joining 3 benzene-like structure together. We join it together. So you join it together. Don't mind my drawing, so you can see it. So that's anthracene. So let's put the double bond here. Put double bond here. You put here. So you put one here. You put another one here. You put another one here. Then you put another one here. You put another one here. So you now draw it. So this is what? Anthracene. So this is the formula for anthracene, and the molecular formula is C14H10. So that's anthracene. So now that's for aromatic compound. Now let's go to arenes. So you'll be surprised seeing arenes. What's the meaning of arenes? Arenes is the combination of combination of aromatic and aliphatic compound. So they are both aromatic and aliphatic compound. So they are somehow different. So I'm going to show you the structure now. So let me show you their structure in the next slide. So this is how they look like. I think you know that this is not benzene. This is not benzene. If you count the number of sides, it is not benzene. 1, 2, 3, 4, 5. So this is not benzene. So 1, 2, 3. 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5, 6. So it's still benzene. Sorry, it's still benzene. So but they try to take, you know that this is how benzene normally look like. They try to invert it, change the direction. So it's also benzene. So now they now join it to, what happened in aromatic is that benzene is the simplest compound. They now join it with what? Aliphatic. If you look at this is aliphatic compound. They now join it with it. So this is what we call Arene. So Arene, they are combination of, this is what? Aliphatic. And this is what? Aromatic. So that's its aromatic compound. So both of them, they now form what? Arene. I hope you understand. So that's that. So now in aliphatic compound, we have something we need to know about them. They have some peculiar thing, but I'm not going to explain it in this video, so I need to pause this video for now so that I can continue in the next chapter.